Right, here's some high-end subtleties about the cross product. First of all, you've got to be able to do it. It's got the formula there. I'll just show you how I do it. I go to the first box and I ignore this first row because I'm on it, and I do a cross. That's why it's called the cross product. 2 times 1, take away 4 times 12 is minus 10. Then I go to the bottom and I ignore the bottom and I do a cross of these. 1 times 4, take away 2 times 2, that's 0. And then I do the middle one. I do this one last because I have to remember to shove a minus sign in front of it. So this is 1 times 1, subtract 6, that's minus 5, and so I write plus 5. So make sure you can find a cross product. Now, I think you all know that the main use of this is it will help us find the area of the triangle that these two make. So this one is V, and this one is W. Then they form a triangle, and actually they form a rectangle, not a rectangle, a parallelogram. And the area of this parallelogram is simply the length of this vector. This is on the formula book. The length of the cross product, the magnitude of the cross product, is equal to the area of a parallelogram. It's just that we don't normally use it for parallelograms. We normally use it for just triangles. So the area of that is half of the length of that. So I hope you knew that. So this is V and this is W. What would this look like? Well, I'm going to switch to a bit of software to draw it. So here's my V and W. They're two vectors, and this is the cross product. And if I just move this is the three-dimensional diagram. Can you see that the cross product is perpendicular to both W and V? So this is the big property of the cross product. It produces a vector. Given an input of two vectors, V and W, it will find you a vector that is perpendicular to both of those. And sometimes that's a useful thing. So there's a property. And you can think of this as, get your right hand out and think of the two input vectors as your fingers. And then the cross product will be your thumb sticking up. Can you see your thumb is at right angles to both of these fingers? Even these two fingers don't need to be at right angles. But your thumb will be if you stick it up. It'll be at right angles to both. And this is how you know the direction of the cross product. That it is obeying the right hand rule of, there's the first vector on the left hand side of the cross product. There is B on the right hand side. Well, this will be pointing up as you see from this diagram here. The knock-on effect of that is that A cross B will be the negative of B cross A. That is like turning your hand over here. If you swap these two round, you're going to end up pointing your thumb downwards. Lastly, if you look at the formula book, it does tell you there is a formula for the cross product that is different to this formula. This is the one you should use, but it's also equal to this. It doesn't tell you actually the formula for the cross product. It says here's the formula for the length of the cross product. And the main manifestation of that is that A cross A, obviously that is meaning cross a matrix with itself. The length of that will be 0. So there you are.